Hey Geometry, and what we're going to do in this lesson is 3.6 and we're proving lines perpendicular. That's exactly what we're going to be doing. We're going to be learning theorems about perpendicular lines and how to prove these lines are perpendicular. So let's get started. Alright, so here's a warm-up exercise referring to perpendicular, intersecting lines that are perpendicular. It asks us, what is the measure of ABD? What is this measurement right here? If we know this one, DBC, is 90 degrees. Well, since the ABD and DBC are linear pairs, meaning in supplementary they add up to 180, well, the only other thing that this angle over here could be is another 90-degree angle. So we're going to be going a little bit further, and there's a theorem about this right here. So let's look at this definition. You should know the definition of perpendicular lines. Two lines are perpendicular if and only if they intersect at a right angle. Write that down. I'm going to be moving on. Okay, so here's a couple of our theorems from this section. Some of them have names, actual names for theorems, but some of them just say theorem 3.8 or 3.9, 3.10. For these, I will actually give you the theorem on the test and what it states, because I don't expect you to memorize, okay, yeah, theorem 3.8 is this right here, and 3.9 is this one right here. No, not going to do that to y'all. So let's look at these theorems. And I'm going to be looking at these figures that I have over here for each of them. So it says, if two lines intersect to form a linear pair of congruent angles, then the lines are, and your answer should be perpendicular. Okay, and the reason is just like I explained in the warm-up example. These two lines right here form they're intersecting lines, which are a linear pair. These angles are 1 and 2. And if angle 1 and 2 are congruent and these two angles add up to 180 degrees, the only thing that they could be is both 90-degree angles. So that's why, or how we know that these two lines intersect at 90 degrees and therefore are perpendicular. So the symbol for perpendicular is this right here, if you haven't seen it before. It's an upside down T. Okay, 3.9, again about perpendicular things. So if two lines are perpendicular, then they intersect to form 4 right angles, is what you're going to put here. Alright, so if two lines intersect and you know they are perpendicular, you can state this right here about every single angle. You should know that they all 4 are 90-degree angles. Okay, and that's because of this theorem 3.9. I'm going to go ahead and write that again in this blank. Right angles. Okay, so there's theorem 3.8 and 3.9. So here's another theorem that is just noted by a number in this section, 3.10. And here's what it states. If two sides of two adjacent acute angles are perpendicular, then the angles are, and the answer here is complementary. Okay, alright, so here is the same thing, complementary. Okay, so to explain this a little bit more, using this figure right here, this is this figure right here is what this whole thing is explaining. So these two angles, 1 and 2, are adjacent angles, meaning they lie next to each other. They share a common vertex. And if you add up these two angles, knowing that AB and BC are perpendicular to each other, then you should know that they're going to add up to 90 degrees. And two angles that are 90 degrees are complementary angles, as we learned in a previous section. So let's look at this example here. We have it just says find the value of x, and that's what the next three examples ask us to do, is find the value of x. And what we're going to be doing is using these three theorems in order to help us find this value of x. Well, we have a pair of intersecting lines, and we know that one of the angles is a right angle. Well, that means these intersecting lines are perpendicular to each other, and all four angles are going to be right angles. Okay, so that it's using theorem 3.9. You don't necessarily have to state this, but I'm just explaining our way through this. But to solve for x, knowing that this angle is 90 degrees and this right here is x plus 25, we can say x plus 25 is equal to 90. And we can find our x value from it. So subtracting 25 from both sides, you get x equals 65. Okay, again we're going to be finding the value of x, and this one right here, this first one that we're looking at on this page, is we're going to still be using that theorem 3.9 for this. If we know that these two lines intersect each other and you have a right angle right here, then they're perpendicular, meaning all four angles are right angles. And this right here, these two angles should add up to 90 degrees, and that's kind of part of theorem 3.10. So, knowing the fact that these two angles, 51 degrees and 2x minus 11 degrees, are complementary, they add up to 90, we can set up this equation and solve for x. So here we're going to get 2x, and I'm going to subtract 51 and add 11 to both sides of the equation and get 50. And 50 divided by 2 is 25. And we're done. Okay, this last one is using that theorem 3.10. We know for a fact that these two adjacent angles, are going to add up to 90 degrees. So set up that equation, that x plus 5, well, we don't necessarily need the parentheses, let's take it back. The x plus 5 plus the other angle, x minus 15, is going to equal 90 degrees. So solve this for x. We're going to get 2x. This put together gives us minus 10. Add that to both sides. We get 100. Divide by 2. Get 50. There we go. So here are values of x for these two. And that's how you're going to be using or applying these theorems. Okay? Alright, so example 2. We're going to be using all the theorems and things we know from previous chapters 2 to help us in figuring out all of these angle measurements that we're asked to find here. Let's just start out. Angle 1. Well, it states that angle 1 is a right angle. Okay? The symbol right here tells us it's a right angle, meaning it's 90 degrees. Well, this right here, if that is 90 degrees, then this is 90 degrees. Actually, all 4 angles are 90 degrees. So, angle 2 and this angle measurement that you see at 60, those are going to be added up to get the whole 90 degree angle. So, what's left over from 60 after subtracting it from 90 is 30 degrees. So that's our angle 2 measurement. Alright, I'm going to kind of skip around a little bit. If we know that the measurement of angle 2 is 30 degrees, well, we should actually know the measurement of angle 4 because those are vertical angles. You see how we have these 2 lines right here intersecting each other, and this angle, 2 and 4, are vertical angles. So, knowing that those are vertical angles, 2 and 4, we know are congruent to each other. So there we go, another 30 degree angle. And same goes with that 60 degree angle that's already written in for us. And angle 3. Those 2 are vertical angles. So angle 3, we can go ahead and say that's going to be 60 degrees. So now let's look at number 5 here. I'm going to erase a bunch of my stuff. Well, it's not letting me. Oh well. So angle 5 and 6 are the ones that we have left to find. And if we know angle 3, this angle measurement, if we know that's 60, and these 2 are going to add up to 90 degrees, I'm referring to 3 and 5. By this angle measurement right here, it says it's a 90 degree angle. Well, 360. So what's left over from 90 degrees is 30 again. So 5 is 30. The measure of angle 6. Okay. Again, 5 is 30 degrees. So 6 is going to be that 60 degree measurement. Alright. So that's using past theorems and postulates and stuff and definitions to figure out what all of these angle measurements are in this figure. And that's what I expect you to figure out, go through that logic of figuring out all these types of angles and their values for them. Okay? Alright, another thing we're going to be doing is proving all of these theorems that I have stated here in this section. So the first one is prove theorem 3.8. And what 3.8 is we're given that angle 1 and 2 are congruent, and from there we should know that G and H are perpendicular. So on this one, what we're going to start out with, as always, is the given information. So angle 1 is congruent to angle 2. And then also, we should know that by definition, that the measurements of angle 1 and 2 are congruent. We don't always have to make this statement, but I'm going to use that in this one to help us in figuring this proof out. Oh, that's supposed to be 2. So this is using the definition of congruent angles. Okay, now kind of to tell you the logic of this, of how I'm going to get to that G is perpendicular to H, is that I am going to show that the measurement of 1 plus the measurement of 2 is 180 degrees because they're supplementary. And then going there from that equation, we're going to see that one of these angles, either 1 or 2, doesn't matter, is a 90-degree angle, and therefore G is perpendicular to H. Okay, so to keep going with that logic, like I said, we should know that the measurement of 1 plus the measurement of 2 is 180 degrees. And that's because in this theorem that it's stated that these two lines form a linear pair of congruent angles. So this right here, a linear pair, we should know is supplementary. So just using the linear pair postulate here. That's what the linear pair postulate states, is linear pairs are supplementary. Now on step 4, what we can do is actually either substitute angle 1 in for angle 2 here, or the other way around. We can substitute angle 2 in for angle 1. Doesn't matter which. Like I said, all we need to do is show that one of our angles, angle 1 or 2, is a 90-degree angle. So I'm going ahead and I'm going to substitute in 1 for 2, because we know they are equal to each other. So in step 4, I substituted. Oops, that's a property. Now, add these together. Measurement of 1 plus the measurement of 1. Well, it's like saying x plus x. So we can say 2 measurements of angle 1 equals 180 degrees. That step there is just, you can call it simplification or combining like terms. And then step 6. Divide both sides by 2 and you get the measurement of angle 1 equals 90 degrees, what we were looking for. So that's using the division property. And the last statement that we need to show here is that since we know angle 1 is 90 degrees, by definition of perpendicular lines, we know G is perpendicular to H. And so that's by the definition of, now let's abbreviate that, perpendicular with the little symbol, perpendicular lines. Okay, and there, we're done. I know that was a lot of steps, but the logic flows pretty well. Okay guys, in this proof, what we're going to be doing is showing that that 3 and 4 are complementary. And in this one, our last statement is going to be this right here, that the measurement of angle 3 plus the measurement of angle 4 is equal to 90 degrees. Because that's the definition of complementary angles right there, is they add up to 90 degrees. Okay, in this one, we're going to be using several of our theorems to get to the last statement. And our first one, we know, is the given. Now, if we know that angle 1 and angle 2 are congruent to each other, and they are a linear pair. Remember, 3.8 told us that if two lines intersect to form a linear pair of congruent angles, which this is, they are perpendicular. So we can go ahead and state that these two lines, QP and PS, are perpendicular. So QP is perpendicular to PS. So that's theorem 3.8. Now, if we know these lines are perpendicular to each other, then they will all four intersect each other at a right angle. And so that right there is using 3.9. And how I'm going to state this is all of these angles are 90 degrees. So I'm going to just set them all equal to each other. I'm going to say measurement of angle 1 equals measurement of angle 2, and that equals this angle measurement right here, QPS, and then SPV. Or VPS. And all of those are 90 degrees. Okay, that is theorem 3.9. Now, the last one is, since we know that this angle measurement right here is 90 degrees, our QPS angle measurement is 90 degrees, and it has 3 and 4 inside that angle measurement, then we should know the measurement of angle 3 plus the measurement of angle 4 is equal to 90 degrees, which is the statement that we wanted to get. Now, that last one was using theorem 3.10. And just to remind you of what theorem 3.10 states, it says if two sides of adjacent acute angles are perpendicular, which is what we knew, that these two adjacent angles are within a perpendicular angle, then these angles are complementary. So there you go. The angles are complementary, and that used theorem 3.10, and we're done with this one. Okay, so here are our last two theorems in this section, and I guess in this chapter. Yay! And these actually have names, unlike the first three that we went over in this section. And these names just go along with what this theorem is describing. Kind of like the consecutive interior angles postulate. It describes what it is. So here we have perpendicular transversal theorem. So let's go over this one. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. Okay, so this should make sense since we know that these two angles right here are going to be congruent, then that angle that I just marked has to be 90 degrees. These two angles that that we're looking at right here, this one right here and this one right here, are corresponding angles. So yeah, if these two lines, H and K, are parallel to each other, then these corresponding angles are going to be congruent to each other. Meaning, if we know one is 90 degrees, the other one's going to be 90 degrees also. So, J and K are perpendicular. Now, this other one, it's kind of in reverse. We know that these two angles right here, or we know these two lines are perpendicular to the transversal. That's why it says lines perpendicular to a transversal theorem. So in a plane, if two lines are perpendicular to the same line, then they are parallel to each other, is what that should state. So if we know that this right here and this right here are both 90-degree angles, because we know that they're perpendicular to this line down here on P, then these again are corresponding angles, and if they're these corresponding angles are congruent, then these lines must be parallel. Okay, so I'm going to mark this that M and N are parallel. So that is the perpendicular transversal theorem and the lines perpendicular to a transversal theorem. And we're going to use those in an example here. Okay, in this last example I have for you, we're going to be answering these questions and then explaining. The explaining is going to come from our theorems that we just looked at. Okay, so first one asked, is C parallel to D? Well, the answer is yes. If we look at it closely, C and D are going to be parallel because they're both perpendicular to this same transversal A. And that right there is using the lines perpendicular to a transversal theorem. Say yes. By lines perpendicular to a transversal theorem. Okay, now the next one is B perpendicular to D. Well, let's look at this. We know from part A that C is parallel to D, and we also know that C and B are perpendicular. Well, if we know this, then we can use that first theorem that we just looked at on the previous slide, the perpendicular transversal theorem, to say, well, if these lines are parallel and this right here, the B and C are perpendicular, this one must be perpendicular too, because they're corresponding angles. And that is using that perpendicular transversal theorem. So say yes here by the perpendicular transversal theorem. And we're done. Okay, on these next couple of slides, I have some theorems, some proofs for you to write down again, and we will cover these in class, just like we did the other day. Okay, so copy these down. So what we're going to be doing is proving these theorems. So we're going to prove the perpendicular transversal theorem, And then we're going to prove this theorem. So pause this video, take your time, and draw these figures and write out the given information and what we're supposed to prove. And we'll finish these in class together. All right. I will see you all in class. Goodbye, everybody.